Hello everyone. Today's topic is Special Theory of Relativity Part 1. Special Theory of Relativity was given to us by Albert Einstein. We all know what a wonderful genius this man was, but what exactly did he do? He told us something very profound. He said that space and time are not absolute quantities. He said something that completely defies common sense. If you have a man A standing on Earth and another man B in a spaceship which is flying very fast through space at nearly the speed of light, then A and B will make different measurements of length and time. The only thing constant for them would be the speed of light. Now, Einstein made two assumptions before he derived special theory of relativity. His first assumption was that the laws of physics are the same for all inertial frames of reference. What is an inertial frame of reference? Suppose you have a man A standing on the road and another man B in a car which is moving at uniform speed, then both A and B are inertial frames of reference. According to Einstein, the laws of physics will be the same for both of them. However, if you have a man standing on the road and another in an accelerating car, the accelerating car is not an inertial frame of reference, and the laws of physics will be different for the accelerating car. The second assumption that Einstein made was that the speed of light is a universal constant and it does not depend on the speed of the source or the detector. This law was verified by an experiment performed by using the Michelson-Morley interferometer. Now, using these two assumptions, Einstein formulated the whole of special theory of relativity, and it's led to very interesting results. One of them is time dilation, which I'm about to explain. So, let's imagine a thought experiment. We have two observers, A and B. A is standing on the platform, and B is in a train which is moving with a velocity u towards the right with respect to A. Now B puts on a light and the light beam gets reflected by a mirror fixed to the ceiling of the train. For B, the light beam follows a straight line path up and down. I'll show you. However, for A, the light beam follows a zigzag path like this. This happens because by the time the light hits the mirror, the train has moved. Now there are two events. There's B switching on the light, and the second event is detection by detector. Now both are trying to measure the speed of light. Now the speed of light, according to Einstein, will be the same for A and B. Now let us see what time they will take. For B, the time will be 2h by c. Where h is the height of the compartment and c is the velocity of light. Now for A, the length traveled by the light beam is larger than that by B, but the velocity of light is same for both of them. The only way this can happen is that the time interval measured by A will be different from the time interval measured by B. So for A, the time interval will be the length of the zigzag path, divided by the velocity of light. So we see that for two observers moving with respect to each other, the time duration is different for the same event. This is known as time dilation. Time dilation has been observed in particle physics. Muons, which are elementary particles, travel at very high speeds in the atmosphere. And they survive longer than expected because they're traveling at speeds very close to that of light. Thanks for watching. Have an amazing day.